Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about algebra. Now the question I've chosen to go through here is 2019 Paper 1 Question 3 Part A. In this question we're asked to factorise fully and we're given 4 terms. This is actually a junior cert question. It comes up in the junior cert almost every year, but the problem is when it pops up in the leaving cert, students haven't revised it, so you might just be a little bit rusty on this one. It's very straightforward to factorise this one. We just take the first 2 terms and we factorise out what's common. The number that divides into both is clearly 3 and the common letter is x. So I can factorise 3x out of the first 2 terms. 3x into the first term is y, 3x into the second term is minus 3. I do the same thing with the next 2 terms. I'm going to factorise 4y minus 12. The only thing that'll factorise out of both of them is a 4. So if I factorise out plus 4 into that gives me y, plus 4 into minus 12 gives me minus 3. Now I know that I'm on the right track because I have the same thing in both brackets. If you have the same thing in both brackets, my final answer, I just need to write it as double brackets. One of them will be the bracket I already have, which is y minus 3. The other bracket is what's outside the 2 brackets. In this case, 3x plus 4. So I've got 3x plus 4 in this bracket, y minus 3. And that's it factorised fully. If you now went and multiplied out these double brackets, we'd end up back where we started. But my final answer in this case is this. In part B, we're given another function and we're asked to solve it. So we've been given the function g of x. We've been asked to use our answer to part A in order to solve it. Now you should realise that what we had in part A and what we have in part B is basically the same thing. The first term in part A was 3xy. I now have 3x ln x. In other words, the y has been replaced by an ln x. Instead of minus 9x stays the same, minus 12 stays the same, but in the third term instead of a y I have ln x. So basically all they've done is they've substituted ln x for y. Now you should realise that in the first part of the question we factorised 3xy minus 9x plus 4y minus 12 and we got 3x plus 4 times y minus 3. If you factorise the top, that's what you get. So obviously if I factorise the bottom, I'm going to get the exact same thing, just instead of a y, I'm going to have an ln x. So based on that, I'm basically just copying my answer to part A. So I know that if I factorise this, I get 3x plus 4 times, instead of y minus 3, I'm going to get ln x minus 3. It's essentially the same answer as I had the last time. And now I need to solve it. In order to solve it, I need to let it equal to 0. So my left hand side here is just g of x, and in the question I've been told that g of x is equal to 0. So once it's equal to 0, now I just let each bracket equal to 0 and I solve it. The exact same as a quadratic. If you factorise a quadratic equation, when you get to the stage where you have 2 brackets, you just let each bracket equal to 0 and you solve it. So let's do that now. I can say that 3x plus 4 equals 0, so I can say that 3x is equal to minus 4, so I can say x is equal to minus 4 over 3. That's my first potential answer, but you need to realise that that's impossible. You can't have ln of a negative number. So you can't have ln of minus 4 over 3. So in fact, we need to eliminate that answer straight away. It's no good to us. The one that is relevant will be this one. I can say that ln x minus 3 is equal to 0. So clearly that just means that ln x is equal to 3. Now, a lot of students stopped here in 2019. We need to go further. You need to remember what ln represents. Ln represents log to the base e. So ln is the exact same thing as log to the base e, which means ln x is log x to the base e. That's the same thing, and it's equal to 3. Again, you should look at your rules of logs and your log tables. One of the rules of logs and the log tables tells me that whatever the base is to the power of the answer gives me the bigger number here. So in order to get rid of my logs here, I can say that e to the power of 3 is equal to x. Or in other words, x is equal to e cubed. Because the base to the power of the answer equals the large number. E to the power of 3 is equal to x. And you can leave your answer like that. It's sufficient to leave your x in terms of e because e is a number. So that's my final answer for this part of the question. In the final part of this question, we're asked to get g dash e. In other words, get the derivative of g of x and then sub in e. A very common mistake that happened that year was that a lot of people, the first thing they did was they subbed in e and they worked out a function for g of e. But you can't do that because e is not a variable, e is a number. So you have to get the derivative of g of x and then sub in e into your derivative. So I've done out a little bit of it so far. It's very straightforward to get the derivative of 9x. It's very straightforward to get the derivative of this and of this. Those three terms are straightforward. However, getting the derivative of 3x ln x is a bit more complicated because this is 3x multiplied by ln x. I need to use the product rule. So that's what I've done out here. If I'm using the product rule to get the derivative of this, remember the product rule is in your log tables. It's the derivative is equal to u by dv dx plus v by du dx, where the first thing is your u and the second thing is your v. In this case, my u is 3x, which means the u dx is 3. The derivative of 3x is 3. My v is ln x, which means dv dx is 1 over x. I can get that rule straight from my log tables. The derivative of ln x being 1 over x. So once you get that, you can just sub into your formula for the derivative. I just get u by dv dx plus v by du dx. And it actually simplifies nicely here because 3x multiplied by 1 over x, the x on the top and the x on the bottom cancel each other out and I just get 3. And here just 3 by ln x is just 3 ln x. So that's the only one that's complicated. So now what I want to do is actually get the entire derivative of g of x. The derivative of 3x ln x, I've worked out that is 3 plus 3 ln x. The derivative of minus 9x is just minus 9. And the derivative of 4 ln x, well, the fact that there's a 4 in front of it means that I just rewrite the 4. I don't have to do anything with it. And I just have to get the derivative of ln x. That's one of my rules in my log tables. The derivative of ln x is 1 over x. The derivative of minus 12 is just 0, so it's gone. So now at least I've worked out g dash x, the derivative of g of x. And now to finish this question off, now I need to sub in e and work out my answer to 2 decimal places. So from here it's relatively straightforward. I started off with g of x, I found the derivative g dash x. Now I want to get g dash e. In other words, everywhere there's an x, I'm just going to sub in an e. All I did on this line was I simplified it because 3 minus 9 gives me minus 6. But at this stage, these are all numbers, so you can just plug that straight into your calculator, and the final answer to 2 decimal places is minus 1.53. So I hope all of this video makes sense. Let me know if there's anything you're struggling with there. Send me an email or ask me in class, and I'll try and explain it a little bit differently.